Hello everyone and welcome to Physical Science. We are going to be working with chemical reactions today, specifically types of chemical reactions. So this is Unit 4, Section 2. So down at the bottom you can see an example of a chemical reaction occurring where you have two separate substances combining into one substance. So we're going to look at the types of different chemical reactions. The first one we are going to look at is combustion. Combustion is really just the burning of hydrocarbons, and you may be wondering, what is a hydrocarbon? So let's write the burning of hydrocarbons. Hydrocarbons are anything that contain carbon and hydrogen, and sometimes they'll contain oxygen. So it's either CH or CHO. We are examples of hydrocarbons. Wood is an example of a hydrocarbon. If it is alive, or was alive at one point, it is considered a hydrocarbon because we are composed of carbon, hydrogen, and oxygen. Well, guess what? If we were to burn in the presence of oxygen to produce heat, that would be considered combustion. So combustion is the burning of any type of hydrocarbon. So the products, you will always end up with predictable products in a combustion reaction. It will always be carbon dioxide and water. In fact, right now you are undergoing combustion. Your body is going through a series of digestion processes where it is taking hydrocarbons, which contain carbon, hydrogen, or CHO, carbon, hydrogen, and oxygen, and you are breaking down your food to create heat. You release carbon dioxide and water through that process. So you are actually doing combustion in your body, but it doesn't have to be in the body. Burning of wood is considered combustion. So let's get an example. So anything that has C and H plus oxygen will react in the presence of a spark to create carbon dioxide and water. So they will always yield CO2 and H2O. So if you see a combustion reaction and it's asking you for your products, you don't even need to worry about flipping anything around. Just know it's automatically carbon dioxide and oxygen, just like respiration, which is what your body does to break down food. The second type of reaction we're going to look at is decomposition. Yes, it's exactly what it sounds like, to decompose, to break apart. So instead of burning up bodies, now we're decomposing them. Oh. But decomposition is the breakdown of any compound. So a compound breaks down into two or more simple substances. So you start off with something that's combined together all in one, and then it breaks down into two or more different things. There is only going to be one reactant. So if you're trying to identify what type of reaction is occurring, if you have one reactant, you can pretty much assume that it is going to be decomposition because the only thing that can happen to that one reactant is that it can break down. So please write in AB yields, that's what the arrow means, remember, yields, A plus B. It decomposes, it breaks apart, just like the image at the bottom shows you. The red and the blue are combined at one point and then they break apart or decompose. The third type of reaction is synthesis. Synthesis literally means to combine or to create. So synthesis, which I'm going to write as combine, you're going to be creating something. So a combination. So this is combo of two or more to form one compound. Okay, so if you're trying to identify it, this is going to be the one that is only going to have one product, one thing being produced that's all together. So you can see that A plus B, so A is separate and B is separate, are going to combine together to make AB, and now they're all one compound. So go ahead and write in your A plus B yields AB. So you can see down at the bottom another example of two separate things combining into one to synthesis. The next one is single replacement. And it's exactly what it sounds like. You're going to have a compound and one of the elements is going to be replaced. So one element replaces another. So you're just going to have one swooping in. So a single element and a compound are going to be on both sides if you're going to identify a single replacement. So you'll have a single element and a compound, a single element and a compound. But you should notice that there's something going on. There's a flip-flop going on between A and B. This is like the home wreckers of the chemical compounds, where A swoops in and C's more attracted to A than B, and guess what? B gets kicked to the curb. So A plus BC gives you B, now he's all by himself, and then AC. So if you get in that example, A plus BC, so A comes in, pushes B out of the way, and combines with C, yielding B plus AC, single replacement. So there's only one thing being replaced. This one thing is being replaced with A. And you can see an image of what's going on here in color. Then you can have double replacement. This is kind of like the swingers of the chemical world. You're going to end up with flip-flopping of them. So it's not just one coming in to replace another. It's like they're switching partners. Okay, so ions in two compounds change partners. They completely flip-flop. If you're trying to identify a double replacement, you're going to see two compounds on both sides. One compound, two compound, one compound, two compound, and you'll see that double replacement. So A is no longer with B. B and D have flip-flopped. So if you have two compounds on the left and two compounds on the right, you're going to have a double replacement. AB plus CD yields AD plus CB. Okay, so to recap. Combustion is anything that has a hydrocarbon, and oxygen breaking down to create heat, creating CO2 and H2O. Decomposition means to decompose. You're always going to have one reactant breaking down into multiple things. That one reactant will break apart. Synthesis, that's when you have one product. So when you have two things that are separate, combining to make one product, so you end up with just one in the end. Single replacement, a single element gets bumped out. This is the home wreckers where it just bumps one away. So if you had two here plus one here, this one would come in, this one would come in and bump this one out of the way. And then double replacement, you'll have two compounds on both sides, where if you have that compound and that compound, these are going to completely flip-flop. So you have two on the left creating two on the right, two separate compounds. Okay, so they just double replace. So let's look at some examples and try to identify. Well, number one says magnesium oxide yields magnesium plus oxygen. So magnesium plus oxygen is what comes out. We start with one and then it breaks apart. Ooh, breaks apart means to decompose, decomposition. The second one we see is sodium chloride. Ooh, there's a compound. And silver nitrate. So we have a compound and a compound. We have a compound and a compound. And over here we have two compounds again. Well, if I look carefully, I can see that sodium started with chlorine, but now it's with nitrate. And silver started with nitrate, and then it ends up with chlorine. That means that two things were replaced. This would be double replacement, okay? All right, third one. We have H2 and O2. We have two things separate, combining to make one product, one compound. That means that we're making something or combining something. So that is synthesis. If we have silver chloride plus copper, and then let's see what happens. Oh, copper kicks silver to the curb. What in the world? Well, that is single replacement. One thing is being replaced with the other. The copper is bumping the silver out of the way. All right, and then we have C2H6 plus oxygen gives us CO2 and H2O. Well, that one's easy because, well, combustion always gives us CO2 and H2O. The last one, number 6 is sodium and bromide and chlorine, and I see that I have a compound and a separate one. Well, chlorine comes in and bumps bromide or bromine out of the way. So this would be a single replacement. One thing is being replaced because we have a compound and a single. This one we have aluminum and oxygen, aluminum oxide breaking down into separate aluminum and oxygen. So if it's breaking down, it's decomposing or decomposition. And then we have magnesium and chloride, and lithium and hydroxide. Well, we have two compounds here. And I can see that magnesium started off with chloride but ended up with hydroxide, and lithium started off with hydroxide and ended up with chloride. Oh, this is a double replacement because two things are being replaced. So guys, those are our types of reactions. I hope you enjoyed, and have a great day. Has anybody noticed my smiley faces just keep getting bigger?